Hello, my name is Candace Figg, and I'm a professor of instructional technology in the teacher education program at Brock University.
And I am FiggKhirwadkar, an assistant professor teaching the Mathematics Methods course in the teacher education program at Brock University.
Thank you for joining us today. Our presentation will come to you in two parts. The first part of this video presentation will describe the research study conducted with makerspaces in Anjali's Mathematics Methods course. But we find that in most of our presentations, there are always many questions specifically about what we did to implement makerspaces in a Mathematics Methods course. So in the second part of the presentation, Anjali will demonstrate the makerspace in the classroom setup, as well as share some of our evidence videos prepared by the pre-service teachers during their experience. Preparing pre-service teachers to teach in digital classrooms and design learning environments for students immersed in a digital society is a challenge for teacher education programs today. Specifically, pre-service teachers need to be well-versed in how to use digital tools for learning. They need the knowledge to develop 21st century skills in their students, such as those that are described by Batali for Kids, or we used to call it the Partnership for 21st Century Learning. And they need to know how to design inquiry-based explorations that promote critical thinking and problem solving. In the mathematics methods classroom, there is further need to ensure that those 21st century skills also include how to develop mathematical computational thinking. This study explores makerspaces as one possible answer to these challenges. Makerspaces are learning environments that allow open exploration of technologies, both digital and non-digital, which is an effective learning environment for supporting the development of TPAC, or that technological, pedagogical, and content knowledge that a teacher uses when they teach with technology. Over 12 years of research has shown that teachers' TPAC knowledge is built through opportunities to gain familiarity with multiple types of technologies. This builds technical or technological knowledge. Teachers need to participate in modeling demonstrations of how technologies enhance structured and informal learning environments. This enhances technological pedagogical knowledge. And teachers need to make connections through discussions about how different types of makerspace activities map to the curriculum. This enhances technological content knowledge. Plus, teachers need to use critical thinking and problem solving. This promotes technological, pedagogical, and content knowledge. By building the components of TPAC, that knowledge about how to teach with technology is grown or enhanced. In other words, teachers develop TPAC through 4 experiences. First, they need exposure to multiple technologies. Participating in demonstrations where modeling of technologies in structured and informal learning environments occurs. Incorporating the use of critical thinking and problem solving in the learning activities. And finally, engaging in pedagogical discussions to map activities to curriculum. And all of those types of experiences occur in makerspaces. So for the purposes of this study, the investigation examined the effectiveness of makerspaces in the Mathematics Methods course for building TPAC and developing mathematical computational thinking skills. However, makerspaces are not commonly found in kindergarten to grade 8 classrooms, even though it would seem that makerspaces are the ideal learning environment for developing TPAC and computational thinking skills. When informally questioned about reasons for the lack of makerspace environments being established in a classroom, in-service teachers suggested that the lack of structure made it difficult for them to use makerspaces within their classroom practices and spaces. Among the challenges described by the teachers, the most common comment was that making curriculum connections to the unstructured makerspace activities was too problematic. These challenges have resulted in the slow adoption of makerspaces in the classroom, but the proliferation of makerspaces in school libraries and resource centers where there is space and flexibility to house the makerspace abound. Unfortunately, this often delegates facilitation of these very powerful learning environments to librarians who do not have the expertise and pedagogical competencies to sustain makerspace programs. This indicates an urgent need to develop TPAC knowledge in teachers as well as librarians about how to facilitate learning in makerspace environments in classrooms as well as libraries. As researchers, we were interested in exploring how exposure to a structured makerspace in the classroom might influence the teaching practices of pre-service teachers. Our research questions for this study are: what curricular connections do pre-service teachers make for learning mathematics for grades 1 to 5 through makerspace activities? What did pre-service teachers learn about teaching with technology, or what TPAC was developed from exploring in a structured classroom makerspace? And finally, how did makerspace exploration contribute to the development of computational thinking skills in pre-service teachers? Our participants were 69 primary junior pre-service teachers, which means they were seeking certification for grades pre-K to grade 6, and they were preparing to enter their first practice teaching block in schools. The Makerspace workshop took place in one session of the 3-hour classes in the mathematics course. Participants entered the classroom where 5 centers were set up. The students worked through the activities listed here. Anjali will discuss these activities in depth with you in Part 2. Data sources included the researcher field notes and pictures of the artifacts created during the makerspaces. Additionally, data included the transcribed audio recordings from the Explain Everything app, which contained the pedagogical discussions that took place as pre-service teachers collected images of their artifacts, reflected about what they learned, and described the curriculum connections made in the exploration. Finally, participants completed a short questionnaire exit card to close out the workshop. Our findings indicated that participants did make curriculum connections using makerspaces. For example, in the beading stations, teacher candidates used beads of a variety of size and colors to create bracelets, keychains, earrings, many things. At this center, the pre-service teachers connected the grade 2 curriculum expectations for estimation, measuring, and patterning to the activity of making beaded articles. Programming activities provided pre-service teachers with opportunities to think logically and stepwise and to write codes for specific action and movement of robots. At this center, the most noticeable discussion point from the pre-service teachers was that the coder had to code different variables like direction, speed, time, and angle in order to affect the distance covered in one single specific movement of a robot. They connected these activities to the appropriate curriculum expectations. Additionally, our participants connected the curriculum expectations for 2D and 3D structures to the making activities in the origami and the 3D pen centers. They described the origami papercraft as perfect for teaching all about geometrical properties and explained how the 3D pen center made decomposing and composing new shapes, taking the abstract concepts concrete. Our second finding was related to what the participants learned in makerspace explorations about teaching with technology. Participants described how learning contributed to the development of technological content knowledge, or TCK, by connecting tools with the design of content-appropriate learning environments. Participants also described how the pedagogical discussions in the workshop developed technological pedagogical knowledge because they gained understanding about how the appropriate selection of technologies supported learning. And finally, participants were able to use their knowledge of the technologies and the mathematical constructs to determine how time constraints could influence the effectiveness of the learning environment, a clear indication of TPAC. Our third finding was related to how makerspace experiences provided pre-service teachers with opportunities to engage in mathematical computational thinking. Using the 4 key skills of computational thinking as the basis for unitizing coding of the transcripts of the data, we found evidence that pre-service teachers were decomposing, breaking down a complex problem or system into smaller, more manageable parts, then engaging in pattern recognition, looking for similarities among and within problems, followed by an abstraction process, or focusing on the important information only, ignoring irrelevant detail. And finally, using algorithms for solving the problem, or developing a step-by-step solution to the problem, or the rules to follow to solve the problem. We found that all skill components of computational thinking were used throughout the coding and programming robotics centers. Coding movement required working with different variables like speed, time, direction, and the position of the robot. However, decomposition and patterning activities were also used by participants during the beading and 3D pen activities when they engaged in conversations about the patterns they were building with the beads and the decomposition of shapes required to build a 3D object, such as the eyeglasses. The significance of the study is that makerspace activities developed the ability of novice teachers to make creative connections between makerspace learning environments and mathematics curriculum while also promoting an investigative approach to teaching mathematics. Now that you've had an opportunity to hear the research we conducted on makerspaces in the classroom, I'm going to turn you over to Anjali, who will provide you with many more details about the Makerspace in the Mathematics Classroom workshop.
The Makerspace workshop began immediately with a hands-on activity. The participants were asked to create their name tags from all types of beads, paper, buttons, wire, stickers, glitters, markers, and glue. Then participants spent a few minutes browsing through the 5 centers set up around the classroom. They selected a grade out of grade 1 to 6 and 3 centers they wanted to explore and added their names to the charts at the centers. The next activity was then watching a video created by a former graduate of our program who is currently a Teacher of the Year award winner and a Makerspace expert. The link to his presentation created for our Brock students is located in the links below. After watching the video, participants rotated through the 3 centers they selected, with 30 minutes to explore each center. The 5 centers were beading, origami, 3D pens, ozobots, and robots. At the beading center, participants explored beads of different sizes, colors, shapes, and textures. They created various artifacts by applying the different mathematical concepts such as growing and shrinking patterns, estimating, measuring, and the use of non-standard units. They were also discussed. Participants at the Origami Center used papers of various sizes and colors to explore geometrical properties such as line segments, points, different types of angles, and the concept of parallel lines, perpendicular lines, and the intersecting lines. It was amazing to see teacher candidates creating 3D structures from 2D by folding papers at different angles and then connecting different pieces of paper to create 3D structures. The 3D pen center was filled with resources like 3D doodler pens and the different color filaments for creating 2D and 3D structures. This center gave pre-service teachers an opportunity to recognize patterns, decompose structures, and then look for similarities and differences in the structures. And finally, abstract that to the conceptual understanding of congruent and non-congruent shapes. At the Ozobots Center, participants used color coding and the concepts of time, measuring distance, and finding speed to make the Ozobot move. Participants also connected their process of color coding to the mathematical concepts of data management, probability, and integers. Participants in the Robot Center were engaged in problem solving and writing a code, debugging a code, and then shared their excitement and aha moments by making the code work. The Robot Center would be considered more technically challenging because the coding required using the Blockly app. Pre-service teachers then spend 10 minutes reflecting on what they learned from their experiences. They were asked to answer the questions, what connections do you make between the makerspace activities and the mathematics curriculum you must teach in your grade? These reflections were recorded in Explain Everything app on the iPads. The links below will take you to short snippets of these reflections as they engaged in pedagogical discussions about the connections they were making to the Ontario mathematics curriculum and the affordances technology presents. The participants were then asked to meet in groups of 3 to 5 to engage in a pedagogical discussion about what they learned. In their discussions, while relating coding activities to mathematical concepts, they realized the importance of technological compliance of the content as an important factor to be considered when planning an activity using coding. Technological content knowledge is important, but at the same time, pedagogical considerations must be considered for teaching the concepts. Please feel free to contact us at our email addresses as given here on the slides, and we look forward to visiting with you in the discussion board. And thank you so much for listening to us.